Solubility now, which is the ability to dissolve. A solute, in this case sugar, is going to dissolve in a solvent, in this case water. So let's take a look. I have 3 bowls here. They all have the same amount of sugar on the spoon. So you can see that. This bowl has just a little bit of water in it. Can't really see it, so let me shake it a little bit. See? A little bit of water. The one in the middle has quite a bit more water, but the same amount of sugar. And this one has the same amount of water as the middle one, but notice the sugar is not pounded or granulated. It's in a cube or a clump. So the question is, which one will dissolve the sugar the fastest? We put the clump, the sugar amount. Okay. Stir them up. So I'm going to stir all these up. You notice the one bowl that had less water, there's still undissolved sugar in there. You can see it right there, it's undissolved, because there wasn't enough solvent to dissolve it. The one in the middle dissolved everything the fastest because the particle size was very small. There was a lot of surface area that was subjected to the solvent. And the cube, because I stirred it, it also dissolved pretty quickly because it broke apart. But you can just imagine, consider yourself in a, if you guys have ever been around farms, they'll give cows these great big, they call them salt licks. They're big, about a foot cube of salt. Now, do you think those would dissolve very fast compared to a pile of salt? And I think you realize that when the particle is that big, the surface area is somewhat limited, but when you break it apart into little tiny pieces, there's much more surface area that gets exposed to the solvent, so it will dissolve it much faster. Another important variable of solubility, the ability of something to dissolve, is temperature. So this is a packet of hot chocolate. I don't know if you've ever had hot chocolate with cold water. It tastes awful. Okay, and you can see even on top here, it hardly dissolved at all. This is tap water. I can even press into that, and my finger doesn't even get wet. Look at that. It's kind of cool. Surface tension of water is very high. I can push my finger right in there and not even get wet. Let's see how deep. See, I went that deep. See how deep I can go. I'm touching the bottom, and my finger still doesn't get wet. So that shows you water has a high surface tension. Solubility of hot chocolate very much depends on temperature. So we're going to turn on the heat here, and we're going to warm it up and see what happens. Now, after a little while of heating, you can see that a lot of the hot chocolate has actually dissolved. And now, I never stirred it because we already found out that stirring will increase the rate of dissolving. So if you look on the top here, you can see now there's a lot less piles of chocolate there as it heats. So we'll let it continue to heat. Now, a little while later, as it's heating, okay, I'll bring it up here again. You can see the heat's on. We're getting, it's 80 degrees, but notice it's all dissolved now. And it kept getting darker. And if it boiled, it would all just fully dissolve in there. And of course, it would taste really yummy. Another variable of solubility that we're going to talk about later in class is pressure. And there's a law called Henry's law that involves that, and especially used like with skin divers. You know, they have those oxygen tanks so they can breathe underwater. They also need to put nitrogen in those tanks because when they dive down into the water, okay, the pressure changes immensely. And because that pressure changes, we know that that affects the dissolving ability of the gases in the bloodstream. So you may have heard the term the bends. You know, if you dive deep into the water and you come up too quickly, you can have a real problem. Like I say,